Hello there and welcome to the June 2018 paper. Here we're looking at question 8. So a lorry is driven from between London and Newcastle. In a simple model, the cost of journey C when the lorry is driven at a steady speed of v kilometers per hour is this expression here. Find, according to the model, the value of v that minimises the cost of the journey and the minimum cost of that journey. Solutions based entirely on a graphical and numerical methods are not accepted. Now, we're not going to use any of this kind of stuff here. That's if you were to type this equation into the graph, into a graphing calculator, and then work out where your minimum point is just by finding it. That's not what we're going to do. So we're going to do part I, which is to differentiate it. If you're finding a minimum value, you should differentiate. So first of all, I'll write C as a more differentiable form. So 1,500 v to the minus 1 plus 2 over 11 v plus 60. Okay, now we can differentiate it. It's going to be dc by dv. Make sure you use the correct letters there. So you times the power to the front and reduce the power by 1. For 2 over 11v, that's just going to be 2 over 11, and numbers disappear when you differentiate. Now, if we want to make this a minimum value, we need to set the derivative equal to 0 and solve this equation. So the first thing I'm going to do is move that negative part onto the other side by adding it onto the other side. And remember, v to the minus 2 as an indice can be represented as 1 over v squared. So this is going to be 1,500 over v squared. So I'm now going to move the v squared onto the other side by multiplying it onto the other side. So it's going to be 2 over 11 v squared equals 1,500. And then v squared will equal 1,500 times the 11 and then divide by the 2. So 1,500 times 11 divided by 2 is 8,250. And the last thing to do would be to square root to work out what v is equal to. So square root answer equals 90.8. So 19.8 kilometers per hour is going to be the value of v that minimises the cost of the journey. Now we'll move on to part II, and in part II what we're looking to do is find the minimum cost of the journey, so that means plug it back into the equation for C. So 1,500 divided by the 90.8 value. Now I won't put 90.8 in my calculator, I'll put answer button in my calculator. So 2 times 90.8 divided by 11 plus 60. So let's plug that into the calculator all in one go. 1,500 divided by answer button. Add 2 times answer button over 11. And then add your 60. And that gives you 93.02. So £93 approximately. £93 and 2p. No, 3p actually, because it's an 8 after that. So £93 and 3p is the minimum cost. Moving on to part B then, work out the second derivative and show by proving using the second derivative that the cost is minimised at the speed found in part AI. So the first thing I need to do is to recall what dc by dv was, because I'm going to differentiate it again. I believe it was minus 1,500 v to the minus 2 plus 2 over 11. So differentiate it again, d squared c by dv squared, and that will give us plus 3,000 v to the minus 3, and then I need to plug in my value for v, which is going to be 90.8, and let's do that. 3,000 divided by 90.8 to the power of 3, and that would give us a very, very small but positive value, positive 0.0004. Okay, which is positive. And if it's positive and your second derivative is proven to be positive, then this leads to a minimum point. Okay, so state one limitation of this model. So it could be something like other costs could be involved. What happens if there's a traffic jam? Lots of different. So think of other variables that might be included that would affect the price of the cost. So price of petrol, maybe if price of petrol changes, then the cost of the journey is going to change as well, for example. Okay, there we are. That's the answer for question 8 then. Let's now move on to question 9.